All right, so before we even start talking about chemistry, let's talk about the scientific method, which is how pretty much all science is performed. And so there's one step that's the most important in the scientific method, and that's the experiments, right? So experimentation is key, right? So we don't just think these things, we don't just say these things. You have to have proof of what you're saying, and that's all in the experiments. So let's just see how the experiment or the scientific method works, right? So it generally starts off with some sort of observation, right? Someone's just sitting there thinking about stuff or looking at stuff, and then just make some kind of observation. So for example, let's say that we've got this cup of water, right? And then we've got a rock. And then we go ahead and throw this rock into the water. And what we'll observe is that the rock will go down to the bottom, right? The rock sinks. All right. So after you have an observation, you then make a hypothesis. And a hypothesis is basically a guesstimate of what you think happens, or what we can call a proposed explanation. Right? You're going to describe what's occurring there. You're going to think about how this could describe other things, right? So maybe you see this rock sink, and what your hypothesis is that the solids sink. Right? The rock is a solid. You threw it in some water, it sunk. Thus, your hypothesis is that all solids sink, or that solids sink in general. And then comes the third step, which again is really the key step. Right, put a little star there, and that's the experimentation. So we've got to do some experiments. You can't just have an observation, make a hypothesis. You've got to have some experiments that either support or disprove your hypothesis, right? So let's say you go ahead, take another cup of water, and then you think about some other solids that you want to throw in this water. Well, maybe you've got a cell phone. Say, hey, my cell phone's a solid. Let me go ahead, throw in some water, and my hypothesis will say that it sinks. And when you throw that cell phone into the water, it does indeed sink. So this supports your hypothesis. Note that it does not prove your hypothesis, but it supports it, right? So you've got to do some more experimentation, right? You've got some evidence for your hypothesis, but of course, you know that you're not totally in the clear, so you keep doing more experimentation. So next up, you think about some other solids you have in your house, and maybe you come up with an ice cube. So you take your ice cube in water, and you say, well, my hypothesis says that solids sink. An ice cube is a solid, so it should sink. So you throw your ice cube in there, and what you see is that the ice floats. And so that obviously does not agree with your hypothesis because it's a solid and solids should sink, right? So we'll put an X there, and what we'll say is that this rejects your hypothesis. And that's the key point of the experimentation, right? You want to prove yourself wrong. And if you can't prove yourself wrong, or if nobody can prove you wrong, then you're probably right. In this case, you've proved yourself wrong, so you need to move on to step number 4. And step number 4 is also very important, and that's you revise your hypothesis. So science is not set in stone. It's always evolving. It's always changing based on new information that we receive, right? So then maybe when you revise your hypothesis, you think, well, it's not all solids that sink. It's just very dense ones. So you say dense solids sink. And that's your new hypothesis. Once you have your new hypothesis, then you're going to want to go ahead and do some more experiments. Your experiments will revise your hypothesis if you disprove them, and then you so on and so on. Go on and on and on until you think that you have something that is really solid. So again, that's the scientific method. Very simple overall. Make an observation, make a guess, make a hypothesis to explain that observation, and then start doing some experiments to try to prove yourself wrong. And then hopefully you prove yourself right.